Welcome back here for our lesson practice of Chapter 1, Lesson 8. Today we summarize Lesson 8, where we have the functions that we are going to talk about in terms of if it is even or odd. Now, the summary does a pretty good job of giving us a good definition of these things. There's a couple of ways that we're going to want to be able to look at this. For an even function, the function way that we write this is f of x is equal to f of negative x. But the wording that we want to understand is that the graph of an even function is the same when you reflect it over the y-axis, which means the opposite input. So that's where we get this negative x on the inside here, have the same output value. So these two things are equal. And the way that we see that in the graph here is that our input of 4 and our input of negative 4 both give us the same y value of 2. For odd functions, we have this way that we write it here. F of x is equal to negative f of negative x. The graph of an odd function is the same when you reflect it over both the x and y axis, which means the input and output values are opposites. And so, again, what you see here is that if we have an input of 3 that gives us an output of negative 4, then we should know that an input of negative 3 should give us an output of positive 4. And so both the inputs and outputs are switched. So let's see how we can do some of these problems with this lesson practice. So for number 1 through 4, all we're asked to do is determine whether each function is even, odd, or neither. And so for number 1, we are asked which one it is, and I would say here that this is going to be an odd function. The reason for that is because if I pick a specific point, let's say that this point right here, which is positive 3, positive 4, if I look at negative 3, 1, 2, 3, and negative 4, 1, 2, 3, 4, boom, I also have a point there. So since the inputs, if I make the input negative, then it makes the output negative as well. So our first one here should be odd. For number 2, I would say that this one is even. And the reason for that is because when I look at a point, let's say this point right ish here at negative 5, again, I'm estimating a little bit here, but it's about negative 5, positive 2. If I look at positive 5, I get the same y value. So opposite inputs give me the same output. So I would say that's even. For number 3, I would probably say that this one is neither. And the reason I say that is because if I start by trying to see if it's even by reflecting over the y-axis, let's pick a point like right here at 1.5. There's nothing at negative 1.5 on the other side of this. So I know it's not even. When I'm talking about odd, like I can't necessarily take, let's say this point, where do we want to pick a point for? I don't know, negative 6, negative 1. If I look at positive 6, positive 1, if it were odd, I would expect there to be a point there, which there definitely is not. And so this one here is neither even nor odd. And last one here, number 4, I want to look at this here, and it seems to me that this one, at first you may think that it's even because, it kind of has a repeating pattern, but I would actually say that this one here is odd. Let's pick a different color here. Because when I'm looking at this one here, if I were to take this point at the top, which would be negative 3, positive 3, then I go to positive 3, negative 3, and I see a point here. So when the input is negative, it makes the output negative. For number 5 through 6, each graph shows half of a function. We're going to sketch the other half to create whatever type of function we're looking for. So for the first one, we're asked to find an odd function for number 5. And when I do that, let's say in purple here, let's take a point, this one down here, which would be at positive 5 and negative 7 is my coordinate. That means that if I have a point at negative 5, positive 7, that would be this point right here. So I'm going to connect this line at this point, and then it looks like it's just a straight line from here. Because again, if I were to pick, let's say 9 comma negative 7, that means at negative 9, I should also get positive 7. So that gives me an odd function. For number 6, for an even function, I need it to reflect over the y-axis, or the same inputs, the negative input should give me the same outputs. So if I were to pick, let's say, this point right here, that would be at -2, 0. That means +2, 0 should be a point. And then this point, -5, 4, I should have a point at +5, 4. So I have a function that looks like this. And let's get one more point here to make it nice and pretty. So that looks like a -9, -2. So +9, -2. And that gives me my even looking function. All right, so next up, we got problems 7 and 8. Determine the value of b if this function is odd and then even. So for 7 here, we'll do odd. And we see here that b has to be, if it's odd, then it has to be also the negative version of what the input was. So it should be -4. Even the negative inputs should give us the same output. So then it should be +4 here. And again, that's really just focusing on, scroll back up here to kind of our definitions, right? Where if we have an odd function, a negative input should give us the same output. Whereas an even function, that was for even functions. For odd functions, a negative input should give us the negative output. So for number 9, sketch the graph of a function that is both even and odd. There's a couple of different possibilities here, but I'm just going to make the easy one, which would just be kind of a straight line here, all at 0, because that way both the outputs are 0 and inputs are 0. And so it's technically true the entire time. Again, that may be the only actual answer to that one. It's kind of a trick question. I wouldn't stress too much about that. But again, we're really just looking for something that the inputs, if they're negative, give us, the same value, but also the negative value, which has to be 0. All right, so for number 10 and 11, we have our spiral review on this one. And we are asked for 10, the function g of x is a transformation of f of x. Describe the transformation that moves f of x on to g of x. So the first way I would describe this here is that it's probably going to give us a reflection here. But if I were to reflect it over just, let's say, the x-axis to start, it would give me something that looks like this, which it does not look like that. So if I were to take that and reflect it again, then it would land on top of itself. So not only am I going to be reflecting it over the x-axis, I'm also going to be reflecting it over the y-axis. So this one, reflect over x and y-axis. 2 different transformations. The equation of this is really just what we've been looking at for odd functions. And so we have the negative inputs become the negative outputs. That wraps up our lesson 8 practice for chapter 1. Next up will be lesson 9 practice.